it up in parts. So right here, I drew the net for this trapezoid prism. All right, so how many sides are in this diagram? How many sides? Margaret? Count again. 6, right. So when you draw these, you should see 6 sides. So 1, 2, 3, 4, 5, 6. 6 different sides. So what shape is this front side? What shape is that? The front. Jasmine? A triangle and a rectangle. I could do it that way, or simply it is a Hannah. What shape is this right here? Just this trapezoid, right? So if you look at the formula sheet right here, yeah, we can do the rectangle and the triangle, but it actually gives us the formula for trapezoid. So we could just simply use this one right here, a plus b times h divided by 2. If you look at this diagram and this diagram, you kind of have to turn this like this, so that you know this is A, this is B, and this is your height. Okay, so be careful with using a trapezoid. Okay, so formula for trapezoid is A plus B times height divided by 2. Okay, so A is 4, B is 10, and the height of the trapezoid is 8. Okay, so this is probably where some people made the mistake. Okay, so this is your trapezoid. This is the height of your trapezoid. Those are the two parallel lines. Those are your A and B. So 14 times 8 divided by 2. 14 times 8 divided by 2, you get 56. Okay, how many of these do we have? 2 of them. So you have to times it by 2, because for the front and the back, I think that's where some people missed 50. So that means the front and back comes to 112 centimeters square. Okay. The left one, this rectangle on the back right here, what's the dimension of that? It's just a rectangle, so length times width. Bessie? 10 times 3, yeah. That is just 30. Okay. This rectangle right here on the right, so it's just 3 times 4. So it's 12. The bottom, the base, is going to be 8 by 3. So 24. And then this top right here, this rectangle, it's again length times width. But what is the problem? Ivan, what's the problem here? So I'm just looking at this rectangle here. Do I know all the dimension? No, I don't know this. And how do I find that? Overhead. Pythagorean theorem. Whenever you don't know dimension, 99% of the time, Pythagorean theorem. Okay, so this is when we have to break this into right angle triangle like this. Because if you just look at this trapezoid, I can't do Pythagorean theorem. I have to just look at this right angle triangle. So the base right here is 8. But what is the length of this part? How long is that? 6. That's right. Because the whole length is I just killed my trapezoid. The whole length is 10, and if this is 4, that means this right here is 6. So 6 and 8. I'm looking for the hypotenuse, so I'm just simply doing 8 square plus 6 square, and then square rooting it. So 64 plus 36 gives me 100. Square root 100, that means this is 10 centimeters. Okay. So then now I have the dimension of this rectangle, which is 10 by 3 and then 30. There you go. So now I can add this, and this up. Okay? So 112 plus 30 plus 12 plus 24 plus 30. And my calculator is not very good. Let's see. And yes, 208. So total surface area, 208 centimeters squared, right? All right. I think Margaret, is that what you got? No? Oh, Bessie? Yay, good job. Okay. Anybody else got that?
Mine had 208.
Good. I think you added one extra side, was it? All right. So, and then I think some people probably forgot to times 2 here. Some people forgot to do Pythagorean theorem for the last dimension. All right. So, is it possible to see a question like this on the test Thursday? Yes. Okay. So this is the type of question that you'll see. Right? We'll skip example 2 because it's a little too time consuming. So we can just skip it. Basically, it's like you're frosting the cake. So then you have to consider not counting the bottom circle, not counting the bottom circle here, but then adding the top circle. So it's a little too complicated, too time consuming. Okay, so we'll go to example 3. Finding the surface area given the volume. Okay, so EQAO does ask question like this. Okay, so suppose a Campbell's soup can has a volume of 500 centimeter cube and a radius of 4. How much aluminum is used to make this can? Right. So what's weird is you're given volume, but what are they asking for? Surface area, right? So how do they mix? So first off, Campbell's soup. What shape are we talking about? Cylinder, right? So since they gave you volume, this is given. So let's use this then. Volume equals pi r squared h. Okay. So what do we know from this? We know that volume is 500. We know pi is 3.14. And we know radius is 4. So what do we not know? Yeah. Can we solve for height though? Yeah, because we have everything else except for height. So 500 equal 3.14 times 4 times 4, 50.24 h. H. Okay, so how do I solve for h now? After 3 months of algebra, you need to know this by now. You just simply divide. Okay, so h is 9.95. What's my unit? Centimeter, right? Because it's just a length. So h is 9.95. How is that going to help us with surface area? Okay, well, take a look at the surface area formula. Surface area formula is this right here. 2 pi r squared plus 2 pi r h. Okay. Do I know everything? Yeah, I have radius and I just found out what h is. So now it's just simply substituting all the numbers in, and I can find my answer. So 2 times 3.14 times radius, which is 4, plus 2 times 3.14 times 4 times 9.95. Okay. And there we go. Okay. So it's very doable, but you just haven't seen questions like this before, where you have to do both of the equation. Plus 2 times 3.14 times 4 times 9.95. 9.95. Okay, and then when you add it up, oops, 0.48, you get 350. I get this. So if I round it to one decimal place, it's going to be one decimal place. 0.4, right? 0.4. Okay, and my unit, centimeter square. Okay. So EQAL does ask this question. I've seen it before, so you have to solve for this and then solve for this. Okay. So it could go the other way too. They could ask you to solve for this and then solve for this. Okay. All right. So I'm gonna skip to page 21. So page 21. So just some comparison. Okay. EQAL also likes to ask this type of question with a comparison. Okay. Which of the following cone has the greatest volume? Show this mathematically. Okay, so let's just take a wild guess. We'll make our hypothesis. Okay, so no calculation yet. We'll just do a quick guess. How many of you think A holds the most water? So consider these like paper cups. How many of you think B holds the most water? How many of you think C holds the most water? Whoa, okay. Why? Ivan? But why? More wider, okay. Jasmine, what were you gonna say?
I think um area that circle is way larger than the other ones. Though it's not as like tall as the others.
Okay. Okay. Alvin? Sorry, Max?
Because the volume formula for this historic cone, right?
Yep.
I believe it is uh pi r squared pi by n over 3.
Yeah.
And then although c looks like it's only half the height of b, but because the radius it's like twice.
Yeah.
Three
Excellent.
times larger, so
Wow, I have a smart group right here.
so highest
Good. Okay, that is I love all those explanations. So yeah, like when Jasmine said the area is much larger for this one. And then as Max said, because the formula is squared. So whenever you square something, it's always bigger than when you times something. Right? So let's actually figure this out. So let's say let's say if this is R and this is H, so that's the regular one. So height is equal to the diameter of its circular base. Oops. It equals to the diameter, so that's 2r actually. So instead of H, I'm going to say 2r, right? Because it's saying that the height is equal to the diameter. So in this case, it's 2r. Cone B, height is double. So that means this now is 4r. and the diameter is the same. So this is R. Okay, and then height C is equal to that of cone A. So this is again 2R. And then the diameter is twice that of A. So the diameter right here is, that means this is 2R. So if you substitute all these into the formula, you'll see that this one, it will have 4 times as much actually. Because the 2 times the 2 will give you the 4. Do you want me to actually substitute it in, or you guys are okay? Up to you. What do you guys want? Who says substitute it in? Okay, let's substitute it in. Okay, so for A, okay, so A, volume equals pi. We can just leave it as pi because since we're just comparing, we don't even need to use 3.14. Radius is R, and the height is 2R. Okay, so when you simplify this, you'll get 2 pi R cubed over 3. Alright, what about B? For B, same formula. I'm going to substitute R is still R. Height is 4R. So when I simplify this, I get 4 pi R cubed over 3. So this actually has double the volume of this. Let's try C. Pi, your R is 2R, and your height is also 2R. So when you divide all that, you get, this is 4 times 2, 8. So 8 pi R cubed over 3. So now if you compare, you can see that this is actually double the volume of this, and this is double the volume of this. Yeah. And so this is 4 times as much as this one. Right? This is the exponent rule. Remember the exponents we did in chapter 3? So this is 4R squared times 2R squared times 2R. You add the exponents, so that's how you get the R cubed. Everything's coming together. Alright, so this doesn't look like it's like 4 times as much, but if you actually do the calculation, it is. So when next time you get ice cream, you know which one gives you the most. The one with the bowl, basically. The bowl does give you more ice cream. Okay. Draw 3 rectangle with a perimeter of 40 meters. Which one has the greatest perimeter? All right, so using using integers only. All right, so somebody give me one rectangle. When I add up the 4 sides, it gives me 40. Yancy, can you help me with this one? So give me the dimensions. When you add it up, you get 40. 2 by 10. So 2 plus 2 plus 10 plus 10. Yeah, you're a little short there.
Oh, 10 by 10.
10 by 10. Okay, so yeah, we could do a 10 by 10. So 10, 10, 10, 10. Okay, because when you add it all up, it gives me 40. Jasmine? 5 and 15, yeah. So 5 and 15. All right, Farhan? 9 and 11, good. This. Ah, good. I hear. I love the discussion. Okay. Is a square a rectangle?
No.
Yes. Is a rectangle a square? No. So, yeah, it's one of those things where this way is yes, but that way is no. So, a square is also a rectangle because the rectangle property is just 90 degrees and parallel sides. Okay? So it satisfies that. But a rectangle is not a square because not all four sides are equal. Right? So, if I calculate the area, which one has the greatest? Oh, sorry. It should say area. My bad. Because I gave you the area already. All of the perimeter is the same. Okay? Which one has the greatest area? So what's the area of this rectangle? 5 times 15 is 75, 100, and 99. So which one has the greatest?
The square.
The square. And guess what? It's always the square. Okay. Every year, you'll see this question on EQAL. So whenever you see the question asks maximum area, minimum perimeter, they're talking about a square. A square gives you the most optimized. This is like optimization. Optimization. Okay. So if you're gonna remember one shape, remember the square. What's the 3D shape of a square? Cube, right? So same idea. So maximum area, minimum surface area, cube. Okay. And lastly, last example. What is the volume of the space not occupied by the cone inside the cylinder below if both shapes have a height of 10 and a radius of 5? So this is 10 right here, and this is 5 right here. All right, let's calculate it. So let's do cylinder first. Cylinder. So are we doing surface area or volume? Do we want which form? Volume, right? Because we're talking about the space inside. So volume. The volume of a cylinder, pi r square h. Pi square height. Right? So when we calculate that, we get 25 times 10, 250. So 250 pi. I'm not gonna calculate the 3.14 just because I'm comparing two. I'm comparing two shapes. You'll see in a second. It's a little easier to see why. Okay. If you times it by 3.14, that's fine as well. Okay, and then the cone, volume of a cone. What's the formula for volume of a cone? Yeah, Yancy?
Pi r squared h. Oh, pi r squared h over 3.
Over 3. I think some of you already see the connection. Okay, so pi, and then 5 square height divided by 3. 250 divided by 3. 83.3 pi. what's the main difference between a cylinder and a cone then? Yeah. Okay. So for a cone, you have to divide by 3 part. For a cylinder, you don't. So if I go back to like the water example with these, so let's say I have a paper cup, the triangle paper cup, the ones that you get from like the doctor's office, those ones. I fill it with water and I put it in the cylinder cup, paper cup. How many of these will take to fill up one? So how many triangle paper cups will it take to fill up a cylinder paper cup? 3 of them, right? That's the connection between cone and a cylinder. Okay. Same idea though. Okay. If I fill this paper cup full of water, how many times can I fill up this? Actually, let me rephrase this. Okay. If I pour one, if I fill up one paper cup, okay, how much is left in this one? Sorry? 2 more paper cups, or as a fraction? 2/3. Right. Okay. So you have to be careful how they ask it. Every year they ask this question, but it's just different wordings. So I poured out 1/3. How much is left in this one? Or how many times can I pour into this one? It takes 3 of them. Right. So the magic number with a cylinder and a cone is 3. All right. So 3. That's the magic number. All right. The question here was saying how much of the space is not occupied, so that it will be 2/3 of the space. Okay. And if you don't believe, you can divide it, or subtract it, and you'll see that the volume not occupied is 2/3 of the cylinder. Okay. So when you subtract it, you will see that is 2/3 volume of the cylinder. Sorry. Okay, so we just went over a lot of EQAO type questions. So on EQAO, these are the questions that they'll ask. They'll ask you to compare formulas. They'll ask you to compare shapes. Similarly, if you look at the formula sheet here, so we know that the connection between a cone and cylinder is 3. What about a pyramid and a prism? What's the connection there? Pyramid and a prism. How many pyramids does it take to make a rectangular prism with the same dimensions? 3. Yeah, same thing. 3 divided by 3. Okay, what about triangular prism? How many triangular prism does it take to make a rectangular prism? 2. Yeah. What about the surface area? If I were to compare the surface area of a cone and a cylinder, what's the connection there? Nope. Yeah. Surface area. I'm asking surface area though. What's the connection between surface areas? Nothing. Yeah. So when you compare, the connection is always only with volume. There's no connection for surface area for any of these. Okay, I'm not trying to trick you guys. I'm just trying to get you guys thinking. Okay, so good job. So for the rest of the class and homework is just page 22 and 23. I want you guys to do the comparison. Okay, 22, 23. Okay, and then tomorrow we do our review.